We're going to take the derivative of this using implicit differentiation, but we've got to do it twice. So I need somebody, let me see if I remember this. It's going to be xy minus x plus y equals 3. So I'm going to write that down on a separate thing here. So we've got xy, what's going on? It's taking forever. Okay, there we go. Xy minus x, what was the rest of it?
Plus y equals 3.
Plus y equals 3. And so we want the double derivative. Okay. So when I go to take the derivative of this, xy, we got to use the product rule. So the product rule is x times the derivative of y. What's the derivative of y?
1.
In fact, let me change the marker so I can show you guys this. I want to take the derivative of just this thing here. Whoops. Put that in the wrong spot. Okay. So I want to take the derivative of this. And so the derivative of this, we have to use the product rule, right? And so I've got x times the derivative of y, but the derivative of y is 1 times what? dy dx, right? Whenever we take the derivative of something other than x, we have to write dy dx or dz dx or whatever. Now for the product rule, it's plus the flip-flop. What's the derivative of x? 1 times y. So that's the derivative of that. Everything else is kind of the same. So what's the derivative of this? Negative 1. And what's the derivative of this? Positive 1, but it's dy dx. And then what's the derivative of 3? 0. So what I've done is I've gone through this whole thing and I've taken the derivative with respect to x. Okay? Now I can clean that up a little bit. I'm going to say x dy dx, okay, plus dy dx plus y minus 1 equals 0. You guys with me so far on this?
Yeah.
Okay. So then I think the next thing I want to do is I want to get all the dy dx's on one side. So I'm gonna if I factor out dy, oops, I wrote dx. If I write down dy dx and I factor that out, I get x plus 1. And then if I take all this stuff here and I subtract it and move it to the other side, I'll get 1 minus y. Am I right on that?
Yeah.
Does that look good?
Yes.
Okay, so now I just got to solve for dy dx. So dy dx is equal to 1 minus y over x plus 1. But what did the question ask?
Double derivative.
Yeah, y double prime, right? So now I've got to take the derivative of this again. So now what I'm going to do is I'm going to take this whole equation and I'm going to differentiate with respect to x. So on the right hand or the left hand side, I get double prime is equal to. Now for this, I'm going to have to use what rule to take the derivative of this stuff right here? Yeah, so I got to use the quotient rule here. Okay, and so I'm going to let u equal 1 minus y, and then u prime becomes just negative 1 or dy dx. Yep. This one's going to get a little messy. And then v is equal to x minus or plus 1, and then v prime is going to be just 1. Now, who remembers the quotient rule off the top of their head because you studied it for the test?
V prime, v times v prime minus u times v prime all over the square.
V squared. So from this point, we just got to plug that information in. Oops. Well, I'm writing too big. So this is equal to V, which is x plus 1. U prime was what? Dy dx?
Yeah.
Times dy dx minus u, which is going to be 1 minus y, and then times v prime, which is just 1. Okay, all over v squared, which is going to be x plus 1 squared. Okay, I'll pause for a second. Does that look right to you guys?
Yeah.
Did I make any mistakes anywhere?
Negative dy.
Where's the negative
Oh,
dy?
yeah.
Oh, was it negative?
Yeah, it was.
Okay, good. Good thing we double checked, huh?
Yeah.
All right, so this is a little negative sign here. Now the problem is, I've already got it solved for y double prime, but I've got that dy dx.
Right.
But what is dy dx? It's this stuff right here, isn't it?
Right.
So I'm going to take this, right here, and I'm going to insert it right here. So let's just do that. I'm running out of board space. It's a negative dy dx, so I'm just going to take this, and I'm just going to write times negative 1 minus y over x plus 1. Okay? Now, what happens is that this x plus 1 cancels with this x plus 1. Okay? So as I clean this up a little bit, I've got y double prime is equal to negative 1 minus y minus 1 minus y all over x squared, or x plus 1 squared. Now I'm purposefully writing every little step because I don't want to go too fast. But if I have a negative of something and then I add another negative of it, I have two negatives of that, right? Does that make sense?
Yes.
So really what I have here is I have negative 2 times 1 minus y all over x plus 1 squared. Now I gotta go. We're gonna go back and check the answer. I don't know if they push that negative 2 through or not. Yeah, because if you push the 2 through, then this will be positive 2y minus 2 all over that. Yep.
Yeah.
Okay. Thanks, guys. Have a good day.